Hello, good morning students. Already we had seen two codes in a Xilinx last time, that is for a OR gate and the mux. So, and that two codes we are written it by using the data flow modeling style. So today we'll see the how to write down code for the Halfadder by using structural modeling style. So first you have to create new project. You have to give the name first for your project. Now this is the Halfadder. Yes, then you have to select the location. Then this is the project settings. Actually this settings you require at the time of your downloading. Okay, then next, then here you will get the details about the project and the device. Then the next, finish. Now you will get a window where you can create the new source. Okay, so first you have to create the new source. Now you have to select the VHDL module because we are writing our code in VHDL. Now give the file name. Now this file name is nothing but your entity name. So you have to take a precaution that your entity name should not start from any number, any special characters, and by using the logical operators. Okay, now you have to go the next. So in the next window you have to declare your inputs and the output pins. Okay, so now your for the Halfadder there are the two inputs and the two outputs. So A and B are the two inputs and there are the two outputs, sum and the carry. So in the port you have to select input and the output. Now your all inputs and outputs are single bit, so there is no need to select the bus. Okay, and here you can give the architecture name also, that is a structural. Then next. Okay, so here you will get the idea about what is your entity name, what is the architecture name, and which ports you have declared. Okay, now finish. Now here by default your library is available and your small code for the entity is ready. There is no need to write it, but if you want to make any correction, that time also you can make a correction here also. Okay, so now for a structural modeling style, after the architecture, first you have to declare the component. So component is a keyword here. You can see the color for that component word. So it is a keyword. So then component and to. Now for the Halfadder you require the XOR gate and the AND gate. Okay, so now component and to is, then you have to declare what are the inputs and outputs for the AND gate. So now in the port XY to input, then you have to declare the data type as a std_logic. Then the Z is the output. Then this is the data type as a standard _logic. Okay, and after that you have to end this end component. Yes, so your AND component is declared now. Now you have to use one more component, that is your XOR gate. So please recall the diagram for the Halfadder. Okay, so now this is port. XOR to is the component name. Now PQ are the inputs for the XOR gate. Then R is the output for the XOR gate. Okay, so you have to complete it, give the semicolon and end the component. Okay, so here we declared the two components, then you have to go with the begin. Okay, and after a begin you have to write down code for the Halfadder. Okay, so first you have to give the instance name, that is the x1. Then you have to give the component name which we have already declared above, so that is your AND to. Then there is a one port map is required. This instruction is required, so you have to give the port map and you have to give the input and the output. Then the x2, your x2 is your main component, that is a XOR to. So in the XOR to it is a port map A, B and the sum. Now in the AND to your inputs are X, Y, Z, but here the main inputs you have to map. Okay, so that's why X is mapped on A, Y is mapped on B, and your Z is mapped on the carry. So in the AND 2 we are taken as A, B and carry instead of X, Y, Z. Okay, so here your code is ready. You have to save. Okay, so now what you have to do here you have to do one thing. Again you have to select your code, because here you have to create the file for your component. So again you have to follow the same procedure. You have to go new source VHDL module, and the same component name you have to give, which you have declared in the code. Okay, so I have taken as a AND 2 in the code. Okay, which inputs you have taken in the code X, Y and Z for the AND 2. Same inputs and outputs you have to take in the code. Okay, same procedure you have to follow. So you can observe it here. Here will be file created for the AND 2. Okay, so simply you have to write down one line code by using data flow. So Z is assigned as X and Y. Okay, same procedure you have to do. Again you have to go for the main code, new source, then the VHDL module, and you have to write down code for second component, that is XOR 2. Then next, now in the code we have taken inputs and outputs for the XOR codes are P, Q and R. So same inputs here you have to take. Okay. Okay, so here you can see there is a file created for the XOR 2. So again you have to give one line instruction for the XOR gate. R is assigned as P XOR Q. Semicolon. So your file is ready for both components. Here you can see for the Halfadder and 2 and the XOR 2. Okay, 3 files are ready. Now you have to go for the simulation, and when you go in a simulation, first you have to declare which is your main file, that is your top module Halfadder. Okay, so you have to select that file, then go on a iSim simulator, go for a check syntax. Okay, so in the below window you will get behavioral check syntax completed successfully. Okay, and then you have to go for the simulation part. So you have to select simulate behavioral model. Okay, so now here you will get the simulation part. So now please okay, we'll check what's the error here. Okay, so once again we have simulated it. Okay, and we have tried it for the simulation. So here you are getting the simulation window, then you are getting the A, B, sum and carry here. Okay, so you have to give the inputs for the A. Okay, now your A is 1. Select B by using force constant. You have to give the B value. So you have to run it by using this option. So here A is 1, B is 1, you will get sum is 0 and the carry is 1. Okay, so now let's check one more example. Force constant will change the value for A. Okay, A as a 0. Now this is Halfadder. Sorry, it's a B value changed as a 1. Now this is run. So move the cursor here. Then you will get the second option. Yes, so now second option is your 1 and 0. 1 and 0. So you will get the sum is 1 and carry is 0. Okay. So here we can verify the truth table for the Halfadder. Okay, same as the another two inputs you can apply and you can verify your circuit. Okay, so this is the simulation part for the Halfadder. Okay, again we go in a code. We'll see the diagram, how that diagram will generate. We'll go in a synthesis window. Okay, we'll see the RTL schematic. Okay, let's see what's the problem here. Okay, here I am getting some problem. Please wait, we'll try. Okay, so in the synthesis you have to select the view RTL schematic. Okay, so here in the below window you can check the report. There is a synthesis report create. Okay. Okay, let's see. This is the RTL view for the Halfadder. We had seen there is a B. There are the two inputs A and B we have declared in the code, carry and the sum. These two are the outputs. Okay, and this directly diagram will be created here, and this is a structural. Let's see why we are written as in the main port map code for the AND gate. Instead of XY we are taken as a AB because X is mapped on A and Y is mapped on B, and same here Z is mapped on carry. So that's why in the code we are directly taken as, instead of XYZ we are taken as A, B and the carry. Okay, same your P is mapped on A, Q is mapped on B and R is mapped on sum. So in the XOR also we are written as port map in bracket A, B and the sum. Okay, hope you will get the whole idea about this modeling style. So let's see, this is again an internal diagram for this. So this is AND gate is created here. So when I click it here, there is a XOR gate is ready. Okay, so when you select this diagram, all notifications or whole circuit diagram will be ready for you. So for your write-ups you have to create this RTL schematic and you have to enclose this diagram for our write-ups. Okay, hope you understood all these steps. Okay, so thank you students. We'll see in the again next code in the next week. Thank you.